Hello, my name is John Kusi, and I'm here to take you through the introductory part on PLC one-on-one. And I'm going to guide you with the simple steps that will help you to understand PLCs better and how you can program your PLCs using ladder logic. But first, you have to be able to get to the interface where you can program. How do you get to the interface? First, you must understand the kits. So I'm going to take you through the various steps you should go through and also some of the physical items or components you will find when you see an automated kit, especially the one for training. So we are using PLC, circuit breaker, 24-volt converter, switches. This system needs a power to work. So this is the power supply section, this is the circuit breakers. This is 240 to 24 volts DC converter, and we have the terminal block. This is HMI, that is human machine interface. Okay, that is the human machine interface. HMI. This is the PLC itself. These are the digital simulators. It's up to 8 bits. So this is 0.0 at 0.7. These are the digital simulators. These are the inputs that we'll be using to simulate it. Okay. And anytime you trigger any of this, then from the 0.1 to 0.7, this is the inputs. The light will come on for us to know whether it is on or off. So anytime you give a logic 1, the lights will come on. These are the analog signs. This is the outputs. We have connected this our motor which we are going to run. And the motor is in series with this light because the output voltage is 24 volts DC. And this motor is 12 volt DC. So we are connected in series with this LED light, which is also 12 volt DC. So they can share the voltage together. Okay, these are the terminal blocks where we are taking our outputs to supply to the motor. So the motor is connected from the coils. It's connected from the K0.2, the output there, as indicated there. This is just a switch to link the device so that they can communicate to each other. On your desktop, after the software has been installed, double click on the TIA icon, the TIA. That is the Total Integrated Automation icon. You are using Siemens engineering systems. These things are coming from Siemens. So it's important you understand and learn how to program these machines that is going to control your future. Okay, so then you come to create new projects at the Total Integrated Automated window, the portal. When you get to the portal, then you come to create new projects.
I wanna be the one you look onto when you're down. I wanna be.
Project name, you should type a name for it. So let's say Johnny 1.
The one who sees beyond the sky. Every dream got a man behind it. Cause I don't know, you need to be reminded. I never saw you, but it changed my life. And I'm a.
Then after that, you click on create. Then you should wait for creating projects wizard to create your project for you.
Let me tell you something, need to keep stay in and out of trouble, still at 6 feet. But what kind of life are we gonna live when the trouble comes and it's chasing all our dreams? No matter what it do, people fall at it.
So once the first step has been taken, you need to configure a device. So the next thing you should do is to configure a device. So when you click on configure a device, it will take you to the window, but here no device has been added yet. So we have to go to add new device. Then you see the HMI, the controllers. The controllers are the CPUs, which are the PLCs. You may know the exact PLC you are using, then you can select here. But if you don't know, you can choose unspecified, then you can detect it. So we are going to choose unspecified because I may not know the PLC type you'll be using. So the CPU type you'll be using for your PLC. So let's choose unspecified. So I'm going to choose unspecified here so that we can detect it further. Once that is done, then the article number will display with the lowest number version possible. So once you have that version available for you, then you can go ahead and add it. Then after that, you have to come to detect, because as you can see, the PLCs has not been detected yet, so it's faded. It doesn't know the kind of PLC you are going to work with. It's important you click on detect so that you can detect the exact PLC you have connected to the PC or your HMI. That is a human machine interface. Detect, because you have to detect your device, but this time the system doesn't know which CPU you are using for your PLC. Yeah, make sure PN/IE, that is the Ethernet connection, has been selected. Then check if the Realtek has also been selected. Then you click on start search. Once there is a green light between your PC and the PLC, it means it's connected. Now you can come to detect. So you click on detect. Okay, so once you click on the detect, you should wait briefly.
If you scare me to run away, just for standing in for when you can tell me every day.
It will appear, it's going to appear yes. Now the PLC has been detected and it has appeared. So if you maximize it, you can see that it has .0 out to .7, that is 8 bits digital inputs and some analog inputs there. And also when you check down to, you can see that it has also 8 bits digital outputs and also some analog outputs there. So now that our PLC is ready, then you can go to the stats. Click on start, then check PLC-1 CPU, click on the drop down arrow there, skip to program blocks. At the program blocks, double click on the arrow there, the drop down arrow, and double click on the main OB to open the interface where you can begin your programming. Like I earlier on said that we are going to use ladder logic to program. So it's important you understand this kind of programming language, because that is the one we are going to use. And I said that it's built based on the old industrial way of controlling motors and drives. So because they want to control drives, they were using contactors. There's normally open contactors, normally closed contactors, coils. So here we are going to use normally open and normally closed contactors as our inputs. Then we'll be using the coils as our outputs. So that is our normally closed contactor. The two of them, the blue is our normally open contactor, and the red is our normally closed contactor, plus other lines that we need to use them as connectors. The green is the coil, and always we use the coil as an output, and the coil must be the last thing to appear. If you want normally open contactor, you drag it and drop it at the line. When you see a small box which checks the green color on the small box, when it indicates on the line, you release your hand and to go there. The red question marks, you double click on the red question marks. If you double click on the red question marks, then it will allow you to introduce it, whether it's an input logic or it's an output logic. We introduce an input logic with I, and we declare an output with Q. So you right click on it, then you go to rename tag, so I can give a name to the input you have declared. So now we are calling normally open contactor, or you can decide to call it NO. That is normally open. Then maybe on comment, you can on the comment section you can put the actual name on the comment section or the name you want. That is normally open contactor. Okay, once that is done, so you drag the normally closed one there, make it I 0.2 as an input. You press enter, and let's rename it normally closed contactor. Rename tag, you right click on it and go to rename tag, and the name section you change the name to NC. Then you can pass a comment, maybe call it normally closed contactor. Of course, pass any comments and I will read them, and if I have to improve anything, I will improve that. If you need anything, you can pass a comment, or you can always contact me. Then click on change.
Paying back for people mistake. How do you chill? That's why I take the lead, sit by the papers, reading script, and I start cleans and comments. Can you make a promise? Can you stay?
The normally closed and normally open are used as inputs, and we are using the coils as an output. Now we need to bring an output to this side. So let's pick the coil. Okay. Now you have to bring your outputs. Drag the coil. Green light shows, release your hand. Now double click on question marks. Here the question marks. Then type Q 0.1 because we introduce an output to Q. Just rename it. What do you call it? Maybe, yeah, LED lights.
Can you stay out of those lies? Say I promise.
Or LED 1. Okay, LED 1 is okay. So let's use LED 1. Then maybe let's call it what? The main lights. So that is our main lights. So now that we have this, what can we do? Now the circuit is complete. With this, so we can compile to check the syntax. If there is no syntax error. Once the comparison is done, you check if there is error 0, warning 0. When there is a warning, there is no problem. But when there is error, then there is a problem. And we have to trace the error and solve it, as we cannot simulate or run that program. Once you right click, yes, go to download to device. Then load. So as we are loading, we should wait. Loading completed, error 0, warning 0. So our loading is completed and it's error 0 and it's warning 0. So now let's simulate it. We simulate by clicking monitoring icon. We are going to use the online monitoring icon to simulate. Then you click on that spectacle, the last but 20, that is the online monitoring icon. Good, so the green light indicates current. So the supply power is there. So whenever it's on, you see the green light indicating that it's on. So now we are going to simulate it to see how our LED, the light will come on. Good, so the normally close is on because it's already receiving logic 0 and it's supposed to be on because it's normally closed. Normally open is closed. The output will receive power and now it will conduct. The normally close is on because it's already receiving logic 0 and it's supposed to be on because it's normally closed. Normally open is receiving logic 0 now and it's also off because it's normally opened. Our output is not conducting. So when the normally open is closed, the output will receive power and now it will conduct. This introduction will take you to the interface and it will help you to start the programming. Next time I'm going to take you through how to use the timers. So it's very important you understand how this is done. So maybe I have to introduce you to a few of the timers to help you to understand the timer operations. Then we have time pause delay, we have time on delay, we have time off delay. So I've picked time pause delay. You just double click on the question marks. Then you can type, you don't need to memorize the syntax in your mind. Just type 10, press enter and it give you in 10 milliseconds. Just click on it, take the M out, that is the milli out. Then you come to the ET, that is elapsed time. The first one, PT, is the preset time. Now you have to keep your time in the memory data. So maybe keep it at MD2 so you can feature use it for anything you want to use it for. So MD2 memory data 2. Once that is done, in is connected and Q is connected to the output. So now you can compile your system and download it to the PLC. One is downloaded. Let's simulate it by going to the online monitoring icon. Good. Let me also state that these were donated by Siemens to KNUST for learning purposes. To help students and workers and other people who want to learn more about PLCs or get more understanding about the course and the device itself. And I think Siemens products are one of the best products you can get in the market, and I recommend that you go for one of them. Very soon a lot of things are going to be automated. Understanding these machines and how to program them yourself is very important, because when they take over the jobs, you can become their boss. PLC is something you must get it, and I'm hoping to always see you on this platform. My email is part of the small write-ups down there. You can check that site and you can send me an email if you want. Enjoy the practicals yourself. You can see me and I can arrange for you to come to KNUST. Thank you very much.